all know airplanes and what they do, and you've also most likely been in one. But do you know about the forces around it? Probably not. We're nerds. Okay, so essentially anything that moves through the air reacts to aerodynamics, which come into the play in the study of flight and the science of building and operating an aircraft. Aerodynamics is the study of properties of moving air, especially the interaction between the air and the solid bodies moving through it. It's the properties of a solid object regarding the matter in which air flows around it. Aerodynamics is primarily concerned with the forces of drag and lift. Drag and lift are caused by air passing over and around solid bodies. Determining the value of the drag coefficient is more difficult than determining the lift coefficient because of the multiple sources of drag.
Drag is the most significant aerodynamic force that applies to nearly everything that moves through the air, and is a force that opposes an aircraft's motion through the air. Drag is generated in the direction the air is moving when it encounters a solid object, and in most cases, is undesirable because it takes power to overcome it. Drag depends on the density of the air, the square of the velocity, kinetic energy, the air's viscosity and compressibility, a measure of the relative volume change of a fluid or solid as a response to a pressure, size of the body, how big is the plane, and the body's inclination to the flow. How can air move around it? To describe the amount of drag on an object, we use a value called the drag coefficient. This number depends not only on the shape of the object, but also on other factors, such as speed and surface roughness, the density of the air, and whether the flow is smooth or turbulent. Forces that affect drag also include the air pressure against the face of the object, the friction on the side of the object, and the relatively negative pressure, or suction, on the back of the object.
The drag equation is D equals CD times rho times V squared over 2 times A. The equation states that drag, D, is equal to the drag coefficient, CD, times half of the density, rho, times the velocity, V squared, times the reference area, A. The coefficient contains all of the complex dependencies and is usually found by experimentation. The choice of the reference area affects the value of the drag coefficient. We'll be using a light aircraft for the example problem. The average light aircraft has a wing area of 250 squared feet, which will be the area, A. This means that we have a drag coefficient of 0.05, CD. The drag coefficient equation is CD equals D over rho times V squared times A over 2. This process won't be shown because we already have our area and coefficient. However, this equation is helpful for reference. A light aircraft typically sticks close to 10,000 feet. The density is a bit more difficult to calculate because you have to take into account the pressure, 29.292, the temperature average at 10,000 feet, which is 23 degrees Fahrenheit, and the dew point, 13 degrees Fahrenheit, which is how much water is in the air. I used a density altitude calculator, but we came out with 0.0564 pounds over feet cube rho. The velocity average of a light aircraft is about 160 knots, which will be our V. So the equation is D equals drag coefficient, which is 0.05, times half of the density, 0.0564, times the velocity, 160, squared times the reference area, 250. We'll put the equation in and solve in order of operations. So drag equals 0.05 times 0.0564 times 160 squared over 2 times 250. We'll square 160 and multiply it by 0.0564, and we'll get 0.05 equals, drag equals 0.05 times 1,443.84 over 2 times 250. Next, we will divide by 2 because we need to keep it in the parentheses. So drag equals 0.05 times 721.92 times 250. We'll multiply it by 0.05 and 250 to get 9,024 pounds over force.
We chose to study aerodynamic drag because it felt like a topic that we could relate to real life and be genuinely interested in. We wanted to know more how planes fly and what forces must be taken into account when flying. We decided to study aerodynamic drag more specifically because there are more factors that we could describe in this video. We felt our learning could be more in-depth since there are so many more factors involved. This video project better helped our understanding of our topic by forcing us to practically immerse ourselves in the process by learning about it. By having to explain our thinking through a practice problem, we had to think more thoroughly about the solving process.